Question 4 is looking at field investigation. So we had a class of 8 students. They measured the population of water fleas living at the edge of a large pond, and this is the method each student used. So number 1, put some pond water into a white tray. Number 2, take a pond net and scoop at the edge of the pond a few times. 3, empty the pond net into the water in the tray. And 4, count the number of water fleas in the tray. The student did not control some variables, so give 2 variables they could have controlled. There's loads we can choose from. We could have size of the net. We could have size of the holes in the net, which would be the gauge of the mesh. We could have had the depth of the sweep. Could have had distance from edge. Could have had number of sweeps. So I'm putting everything I can think of, but it only asks for 2. So when you're answering a question like this, you're only going to give 2 variables. Next, the 8 students then used a different method to obtain valid results. So if they've got valid results, that means they must have controlled some of the variables. And these are the results we have, and it's asking us to calculate a mean value for the population of water fleas at the edge of the pond. Mean value, add them all together, divide by how many there are. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 66 plus 37 plus 51 plus 102 plus 40 plus 122 plus 75 plus 19. And again, it is a bit of a pain to write all this out, but please do it that way so the examiner knows that you're using the correct method. So use a calculator again, don't try and do it in your head, no need. 102 plus 40 plus 122 plus 75 plus 19 gives us 512. Always press equals before you do the next stage, otherwise the calculator might do a BIDMAS error and give you the wrong answer. So 512, and then we'll divide that by 8, gives us 64. So the mean population, 64. What was the range of the students' results? So it's the largest minus the smallest. So our largest was 122. And the smallest was 19. So again, let's use a calculator. 122 minus 19, 103. So suggest one reason why such a wide range of results were found. So this kind of tells me that there's not a uniform distribution of water fleas in the pond. So water fleas not evenly distributed through the pond. Some might live in vegetation, some might live closer to the middle, some might live closer to the edge, so we just don't know. So the next thing that happened was that the teacher sampled the centre of the pond 8 times. His mean value was 12 fleas, so this is significantly lower than the one we calculated. Because there were not very many in the middle, only 12, and when we did it we had 64. That suggests that there are a lot more water fleas around the edges than in the centre. So more water fleas in the edges than in the centre. Next we have a scientist doing a similar investigation. They counted the number of different invertebrates living in a pond in 2014, then 2 years later in 2016. Invertebrates just mean they do not have backbones. Calculate the change in number of bloodworms between 2014 and 2016. So we started off with 13, we've now got 48. 48 minus 13, so final first minus initial, and again let's use our calculator. 35. So there's been an increase of 35 bloodworms. Calculate the number of shrimps in the pond in 2016 as a percentage of the number of shrimps in the pond in 2014. So, well, 2016 number was 9, and in 2014 there were 24, so it's 9 divided by 24. Because it's a percentage, we'll times it by 100, and 9 over 24 gives us 37.5%. It's not specified what significant figures or decimal places they want, so I'm just going to leave it as 37.5, and they've already given me the percentage sign, 37.5%. Invertebrate species found in a pond can be used as an indicator for pollution level. So if we look here, bloodworms, they're fine in low pollution, medium and high, so they're not very good as an indicator species. Whereas if we look at mayfly nymphs, they're fine in low pollution, but medium pollution and high pollution, they can't survive. So if you find water with no mayflies, then that's probably a good indicator that it's polluted. So what conclusion can you make about the change in the level of pollution in the pond between 2014 and 16? So I would say the pollution has increased from low to medium or high. And I know this because if we look at the mayfly nymphs in 2014 we had 32, so that's a good population, but then in 2016 we had 0, so that must mean that it's become more polluted. So there are no mayflies in 2016, whereas they were present in 2014. So we could also have used the freshwater shrimps as well. So the number of freshwater shrimps decreased, but not as much as the mayflies. Last part of question 4. Water pollution and global warming are two problems that have been caused by the rapid increase in human population. Two other problems, we can talk about destruction of habitats, we can talk about deforestation. So loads of other ones we could talk about, but these are the main two that we should focus on.